This is Sarah King, and I'm Director of Product at Molecula. Today, I'm going to share our extraordinary performance when executing joins across virtual data sources that represent disparate datasets. This is a follow-on to our previous video where Matt showed off millisecond exploratory and analytical queries across datasets ranging in size from 100 million records to 1.5 billion records. I'm in our Molecula environment here, interfacing with the Virtual Data Source Manager, the VDSM, using the built-in PostgreSQL client tool to query our virtual data sources. We'll be using the same VDSs that Matt was working with previously, the customers and items VDSs. So to grab a quick count of those, the customers VDS has 100 million records in it, and the items VDS has 1.5 billion and one records in it. I'm going to execute some joins across these two data sets. And for context, our customers tell us join queries like these on this amount of data can take upwards of 12 hours to execute in their existing systems. So this first query that I'm going to run is a basic join query across the items and customers VDSs to give an account of all of the customers that are in the US region and have product 3094. So there are 1,848 customers who have product 3094 and are in the US region, and that query executed in 307 milliseconds. The next query I'll run will do something similar, but we'll add a group by to make it a bit more complex. So we are going to group by region and sales channel on the customer's VDS. And then we're going to filter that by only customers who have purchased product 3094. And then we're also going to do an aggregation on the customer size field. So that query executed in 923 milliseconds. So we just took queries that typically take over 12 hours and reduced them to sub-second latencies. And Molecula does not use any pre-aggregation or pre-processing. And this is all on a single node with 32 cores and 208 gigabytes of memory. And let's just see. It looks like only about 74 gigabytes of memory is actually in use right now. Thanks so much.